Welcome back. Today we are looking at how to find the inverse under any binary operation. Okay, how to find the inverse under any binary operation. The last time we met, we looked at how to find the identity element. We look at how to find the identity element, and I hope you do remember. Today, let's look at how to find the inverse of any given binary operation. Now, when you talk of the inverse, what do you mean by the inverse? Now, let's look at something here. When we take addition, for instance, addition, we said the other time that addition has an identity element of 0. Why? Because any number plus 0 would be equal to 0 plus that same number, and also we are going to get that particular number that we used to add. Okay, so we say 0 is the identity element under the operation addition. We also said last time that under the operation multiplication, we also have an identity element over there, which is 1. Okay, because any number times 1 could be equal to 1 times the same number, and we should get the number itself. And therefore 1 is the identity element under the operation multiplication. Okay, but for the other binary operations, because we don't understand them, we don't know their nature, unless they explain them for us, we can't use them. So in such cases, we have to use the procedure that we used the other day to find the identity element. Okay, now today we are looking at the inverse element, the inverse. Now, what we have to take note of is, without knowing the identity element, we can't find the inverse element. Meaning that before we can find the inverse element, we have to know the identity element. Now, let's look at this question over here. They said an operation, asterisk, is defined on the set of real numbers by m asterisk n equals m plus n minus 1 out of 2 mn. Okay, find the inverse of the general element m. Okay, now meaning that here they say we should find the inverse, but from what I said earlier, we can't find the inverse without the identity element. Because when we talk of the inverse, we are looking at a certain value. For instance, for addition, we know that the identity element and addition is 0. So we are looking for a certain element. Let's take any element under real numbers. Let's say 5. Okay. Now we are saying that 5 plus what number should give us the identity element, which is 0. Okay, 5 plus what number should give us the identity element, which is 0. So here for addition, because we know addition, we understand addition, we can simply say it's minus 5. Okay, so we have minus 5. Now this minus 5 sitting here becomes the inverse of 5. Okay, the minus 5 over here becomes the inverse of 5 under the operation addition, because 5 plus its inverse is given as the identity element. Okay, so that's what inverse simply means: a number or a value that when it is combined with a different number or with itself should give us the identity element under that particular operation. Okay, the operation that they will give to us. So in general, here they say we should use m. Okay, we should find the inverse of the general element m. So in this case, what we do is we test for commutative. Okay, so we have m. Okay, so first of all, let's state it nicely. M exponent -1 be the inverse of m. Okay, we state it nicely, be the inverse of m. Then what do we do here? Then we state that M asterisk M inverse, okay, because we just made an example over here. So M asterisk M inverse should be equal to M inverse asterisk M, and the answer that we are going to get should be the identity element. And last time we said that we normally use E to represent the identity element. Okay, we use E to represent the identity element because you can see that under the operation addition, the inverse of 5 under the operation addition is -5. Why? Because 5 plus its inverse is giving us the identity element. That's what we simply mean. The number which we are using, which is 5, plus its inverse should give us the identity element. So that's exactly what we have said over here. They say we should find the inverse of the general element M. So meaning that M asterisk M inverse should be equal to M inverse asterisk M. And this one should give us the identity element. So this one over here under the addition, whether -5 plus 5 or 5 plus -5 should give us what the identity element, which is 0. Good. So let's look at it. So meaning that we need the identity element before we can find the inverse. Therefore, we have to find the identity element, which is E. Okay, and we said the other day that if E is the identity element, or if E is representing the identity element, then we are going to have, let's say, M asterisk E should be equal to E asterisk M, and this one should give us M. I hope we do remember. So we have two statements over here. Any of them, you can use them inside the system they gave to us. So here, if you take the first one, then we put it inside the system. They said we should write the first number, which is M over here, plus the second element minus half multiplying the first element by the second element, and this system over here is equals to M, okay, because we are expanding this or this, and everything over here is equals to M. So we have our M over here. So what do? We make E the subject, okay? So we take this M to the other side, and we have E minus half ME equals M minus M. Then we proceed to the next line. We have here, because we have E here, we have E also here, so we factor E out, okay? Then here we left with 1 minus 1 out of 2M, okay, equals M minus M, give us 0. Okay, so what do? We divide with that by 1 minus half M, hereby 1 minus half M. So this one will cancel this one off, and therefore our E, which is the identity element, is equal to 0. Okay, so the identity element under this system, which has been given to us, is 0. So now that we have the identity element, we can use the system over there to find the inverse of M. So in this case, let's bring our inverse system down. So we have M asterisk M inverse should be equal to M inverse asterisk M, and this one should give us the identity element. Okay, so now we know that the identity element is 0, so we can replace it, and here we can take any of them. Okay, so we are, in short, we are just using the same procedure of the identity element. The procedure we use to find the identity element, we use the same one under the inverse. Okay, so we take any of them and fix them inside the system they gave to us, which is they say the first one, the first element, plus the second element, which is M inverse, minus 1 out of 2 multiplying the first element by the second element, which is M inverse, and this one is equals to the identity element, which is 0. Okay, so we have our 0 over there. Then you can see we have M inverse here. We also have M inverse here. So let's send our M to the other side. Then we have M inverse minus half M inverse should be equals to, so when this one crosses becomes negative M. Okay, becomes negative M. So at this point we have a M inverse. So we factor our M inverse out. So M inverse out. And then we have 1 minus M out of 2. Okay, we can put it in this way, M out of 2, which is equals to our minus M. Then we divide, because we are looking for our M inverse, divide this side by 1 minus M out of 2, this side also by 1 minus 1 M out of 2. Okay, so the whole of those will cancel this one off. Then we have our M inverse to be equal to minus M out of 1 minus M out of 2. Okay, so this becomes M inverse. Okay, this becomes M inverse under the system they gave to us. Remember that each system that they will give to us will have its own inverse and its own identity element. So this identity element and this inverse does not goes for all of the system that will be given to us. So any system they give to us, we have to first find, if we are to find the inverse, then we have to find the identity element first, then before we can find the inverse expression, okay, or the inverse equation. Okay, so this is the procedure to use to find the inverse.